Hi, I'm Emily Bernhardt. I'm an ecosystem ecologist and biogeochemist here in the Nicholas School of the Environment and also the Biology Department. I think of myself sort of at the largest scale as a watershed biogeochemist, so I'm really interested in how elements enter into, are stored within, and then exit from watersheds. I started working on issues of mountaintop mining over a decade ago. As a child of the Appalachians looking at this landscape, when I went to these places for the first time and drove up on a road where I could see active mines, they look like the moon. And the reclaimed mines look like a Mongolian steppe, And none of it looked like Appalachian mountains, so it's quite striking. These landscapes are largely underlain by limestone, so it's carbonate rock. With mountaintop mining, one of the biggest issues is that exploded carbonate rock has to be put somewhere, and in West Virginia, this really mountainous landscape, they usually put it in river valleys. The rocks in the watershed dissolve at a really high rate. Make that water salty, just loaded with calcium, sulfate, magnesium, carbonates. They often look really beautiful, the water is clear. It's only when you start digging in deeper and actually sampling who's living there that you pretty rapidly lose a whole lot of the iconic species that are sort of characteristic of those systems. That high salinity that's being generated is really difficult for freshwater organisms. We lose almost 60% of the total species out of the 10,000 species we detected through eDNA. I have been really fortunate to have a string of amazing postdocs and graduate students and undergraduates who've worked on this with me, and several technicians. This has been a very much a group effort. In the last couple of years, we've really shifted our focus a lot to selenium, which is itself known to be independently toxic. The aquatic insects in streams draining mountaintop mines had the highest ever reported selenium concentrations in their body tissues that exist in the literature. When those insects emerge from the stream as winged adults, the spiders sitting alongside these mountaintop mine streams had the second highest ever reported body burdens of selenium, which means that this water quality problem is actually leaving the stream in the form of aquatic insects, is entering into terrestrial food webs, and I think one of the next questions that we really need to think about is, what's this doing to the birds in this landscape? Water moves and carries with it all kinds of things, and animals move and carry with it all kinds of things. So the idea that you could ever actually have a boundary on a pollution problem that is as extreme as this, it's hard to imagine how anybody ever thought that was true. I do think we played a role, and certainly I think made it impossible for permits to pretend that there were no offsite impacts or that aggregate impacts don't need to be considered. And so now I think there's a very strong scientific and legal basis on which to challenge decisions like that in the future, and that may be the most important contribution that we've made.